All right, so problem number 66 from chapter 3 in our book says the longest recorded pass in an NFL game traveled 83 yards in the air from the quarterback to the receiver. Assuming that the ball was thrown at the optimal 45-degree angle, what was the speed at which the ball left the quarterback's hand? And so you see I've written down the given information, and then very quickly I just used our friend Google, and we found that 83 yards is equal to 75.9 meters. So at this point, we can pick either the X or the Y to work on. It doesn't really matter. Usually you just pick one, see where it takes you, and if you kind of get stuck, you go to the other. So that's what we're going to do here. So I'm going to start in the X direction with X sub O, right? X equals X sub O plus V sub O xt plus 1/2 a t squared. Again, a is 0 because there is nothing in the horizontal direction causing it to accelerate. Right, so we're left with the fact that it traveled 75.9 meters. Right, X sub O is also 0. Take that to be our origin. And we're left then with V sub O times the cosine of 45, right? And then times t. Okay, so we're left with that bit right there. Cosine of 45 is the angle it was thrown at, V sub O was the initial speed, right, which we're looking for, and t is the time it was in the air, which we don't know. So we're kind of stuck. We've got one equation with two unknowns, so we need a second equation. So to grab that second equation, let's look at the y directions now. So y sub O plus V sub O yt plus 1/2 gt squared. Okay? And when we do that, we know that when the ball is caught by the receiver, it's at a height of 0. And it started at a height of 0. Right? So we're left then with V sub O sine of 45 times t minus 5 t squared. Right? 1/2 of negative 10 would give you t squared. Looking at that, both of the terms that are left have a t, so let's cancel out one of those t's. Okay, and just doing some rearranging, solving for V sub O, right? So sine of 45 is 0.707. We can bring that 5t to the other side, so we'll do 0.707 divided by 5. We're left then with 7.07 t is what V sub O is equal to, right? But I want to find V sub O. So at this point, essentially, we're looking to substitute one of these equations into the other. The way I did it was I just took this equation right here and I put it in terms of, I solved for t, and to find that, right, t is equal to V sub O divided by 7.07, right? Then I'm going to take this whole bit right here and I'm going to plug it in for t right there to get 75.9 is equal to 0.707, which is the cosine of 45, right? V sub O, and then t is V sub O divided by 7.07. Okay? So that's where we are with that. All right, and from there we just kind of do a little algebra to clean it up. So we'll get then 75.9 is equal to 0.707 divided by 7.07 is 0.1, right? And then V sub O times V sub O is V sub O squared, right? And from there we can divide the 0.1 over the other side, then take the square root, and we find that the ball was thrown with a speed of 27.5 meters per second. So pretty fast for a pretty far throw. So that was problem number 66 from chapter 3.